Hi dear students, welcome to Gita's classes. So in this class we are going to do some problems on PCNF and Pdnf. In first part I have explained what is DNF and CNF. So and now we are going to see problems on Pdnf and PCNF. So as I told you in the first class itself, you have to remember these things. R means disjunction and sum, and means conjunction and product. And we have seen DNF and CNF, that is sum of products and product of sums. So in principle, disjunctive and conjunctive normal forms, you must have variables and or its negation, but not both. Okay. So I have explained all these things in the previous class. Those who have not seen, first see that class and listen to that class so that you will have some ideas. So min terms and max terms, we have two variables we have seen. Min terms and max terms for three variables also we have seen. Now we'll do some problems like find the Pdnf and Pcnf of this expression, that is not P conditional Q and P biconditional Q, using truth table and without using truth table. In the exam, if it is mentioned, you have to follow that particular method. Otherwise, whichever you are comfortable with, you can do. Okay. So first let us see with truth table. So I have formed the truth table for this expression P conditional Q, P, Q, and because we have two variables, we have 4 rows. And for this is the last expression we have seen in P biconditional Q and not P conditional Q. This is the expression. For this already I have formed. Now, after forming the truth table for the given expression, we are going to write Pdnf first, then Pcnf. Okay. So first for Pdnf, you consider the truth value of the last column. Consider only the truth values of the last column. That is, consider the rows in which you have the last column t value. Now you consider the corresponding variables in for P and Q. So Pdnf, it is very simple. You are considering t. Therefore, you consider for t you write the variable as it is, and if you have f you write the negation. Now we have both t and t. So we have P and Q. Pdnf means what? Sum of min terms. So these are the min terms. Okay, for min terms, for two variables, we will have 4 min terms. And now we have only 1. Okay, so we have only one t value in the last column. That is why you are considering only that row. So this is our Pdnf, very simple. Similarly, for Pcnf, you consider the false values in the last column and corresponding values. Now you are considering f, no? So if for f you write the variable as it is, and for t you write the negation. Now Pcnf means what? Principal conjunctive normal form. So you have to consider the max terms. Max term means what? R. Okay. So now you consider t means negation of p. You consider the negation. Because we are considering f, for t you take the negation. So negation of p, r, q. Okay. And what is the next term? P, r, negation of q. And last term is p, r, q. And this is conjunctive normal form. Therefore, and between them. So these are the 3 variables. Okay. 3 terms you will have in Pcnf. So very simple by truth table. So if you are writing Pdnf, you consider t and corresponding variables. For t you write the variable as it is and take the negation if you have f. So for Pcnf you consider f terms and corresponding variables for p and q. Because you are considering f, you write the variable as it is for f and take the negation for t. Okay. And now without using truth table also you can find out the Pcnf and Pdnf. Okay. So negation of p, this is the expression given, not p conditional q and q p biconditional q. So this I am going to write it as, now equivalence formulas we are going to apply. So not P, now you have to remove this conditional and biconditional. In the previous class I have explained how to remove that conditional and biconditional. We have two formulas for biconditional, and for this conditional you have negation of P or Q. Okay. So now negation of, already we have negation of P. So P negation of double negation. So P or Q you will have. That is negation of P. That will become P. Okay. So P or Q for the first term. And biconditional we have two formulas. I am going to use this formula, that is P and Q are negation of P and negation of Q. Okay, we have written the equivalence formulas, that is conditional and biconditional equivalences. You have to write the reason. Conditional and biconditional equivalences I have used. So this is equivalent to. Now I am going to use this negation. I am going to take it out. That is De Morgan's law. So P or Q and P and Q are, I can write this as negation of P or Q. Right? I have used De Morgan's law in the reverse order from right hand side to left hand side. So this is equivalent to. Now I am going to apply. Now you have this and here and R here. So I can apply distributive law. So this one term and these two are another two terms. Okay. So P or Q, I am going to apply and over R. So P or Q and P and Q. That is, I have applied this with this. And next term is one second. Sorry. So first I have applied and between these two, and now P or Q and negation of P or Q. What is there in the middle, that you have to write here. That is the distributive law. Okay. So now we have P and not P. What is P and not P? It is F. P and not P is F. So P or Q and P and Q are, this is F. It is equivalent to. Now we have P R Q and this one. So I am going to apply R and. Again distributive law I am going to apply. So P R Q P and Q. This and P R and. Okay. So P and P R Q. Now Q and P and Q. In between you have R, so I am going to write it as R. Now we know P and, please write the last names, okay. For every step you have to write the reason. So now P and Q, both are and only. So P and Q, I can remove the repeated terms using idempotent law. So now Q and Q, again P and Q. This is equivalent to P and Q here or P and Q. Again P or P only, it is equivalent to P and Q. This is our Pdnf. Okay. Pdnf is P and Q. That's what we got now, Pdnf. Now once if you get the Pdnf, then you can find out the Pcnf. So Pdnf of the given expression is P and Q. Now using this table only we are going to find out that. That is P and if you have two variables TT, FF and TF, TF. So what are the remaining three terms? Please remember 2 points here. you will have for two variables, you will have 4 expressions. Okay, 4 max terms or 4 min terms. Now we have this as min term, right? Pdnf. So min term, we have one min term. This is of, let the given expression as yes. So Pdnf of yes is. Now we will have yes and negation of yes will have 4 terms. Together will have 4 terms. Okay. Similarly, Pdnf and Pcnf also together you will get 4 terms. Please remember these things. That is, you will have Pdnf and Pcnf together. You will have, if you have two variables, Pcnf and Pdnf together, you must have 4 terms. And negation and yes and negation yes, that is the given formula, and the negation of the given formula will also have 4 terms. Now Pdnf of yes is, we have written P and Q. Now from this remaining we can write so for this P and Q. Now what are the terms we have? P and Q. Now P and negation Q. Q and negation of P and Q, negation of P and negation of Q. These are called the min terms, right? So one min term we have in yes. So what will be the Pdnf of negation of yes? So remaining 3 terms will be there in Pdnf of negation of yes. Okay. So what are the remaining terms? P and not P. Or not P and Q, or not P and not Q. So this is our Pdnf of negation of S. I told you Pdnf of S and Pdnf of remaining term will be Pdnf of negation of S. Now if you want to find out Pcnf, you have to take the negation of negation S of Pdnf. Okay. So we want to find out Pcnf means negation of yes, that is of Pdnf. Negation of Pdnf of negation of yes. If you take, you will get Pcnf. This is the relationship between Pcnf and Pdnf. So if you take the negation of yes, what will you get here? That is Pcnf is negation of S. This is our Pdnf of negation of S, right? So negation of S. Therefore, the Pcnf is, you take the negation of this entire term. So now you have to apply the De Morgan's law. So wherever you have variable, you take the negation. Negation means you write the variable as it is. So P and AND will become R will become AND. Okay. So negation of PRQ and PR negation of Q and PRQ. Right? This is our Pdnf, right? Negation of PRQ, PR not Q and PRQ. See? PRQ, negation of PRQ, PR not Q. So this is what is Pcnf. So using the table you can find out, or without using the truth table also you can find out using the formula. Please remember Pdnf of given formula if you find out and write the min terms. Remaining min terms will be Pdnf of negation of S. And you take the negation of this Pdnf of negation of S, you will get Pcnf. Similarly, if you have Pcnf, now we have min terms. Similarly, if you have Pcnf, you can find out from the remaining terms, you can form the Pcnf of negation of S. Then again, if you take negation, you will get Pdnf. Okay, that is the relationship between them. Now, we have found out for 2 variables. Let us see for 3 variables also. So, find the Pcnf and Pdnf of this expression using truth table and without using truth table also. So, first let us find out without using truth table, I will tell you. Then we will find out using truth table. Usually, you forming the truth table will be easier. Okay, if it is not mentioned any method, you can form the truth table. So now find the PCNF of not P conditional R and P biconditional Q. So this is equivalent to not P conditional R and now I am going to write it as P conditional Q and Q conditional P. I told you two equivalent formulas you can write. In the first one we have used the other formula. You can use any one of them depending on the requirement. Okay, depending on the question. Now not P conditional R means what? P R R. And now not P conditional Q means not P or Q. Wait, my pen is not writing, 1 second. So not P or Q and this is not Q or P. Not P, not Q or P, right? So I am going to remove, this is and this is also and. I can write it as P or R and not P or Q. And I can write it as P or not Q using the commutative law. Okay. So now this is actually what? Product of terms, product of min terms. Are they min terms? No. Now we have how many variables? 3 variables are there. We have P, Q and R. Okay. So min terms means all the variables should be present either in the form of variable or its negation. So here you have and here Q is missing. In the first term Q is missing. And in the second term we have R is missing, and in the third term also R is missing. Okay. So whatever is missing we have to introduce that variable. How we are going to see that? Here we have in the 2 variables all must have all the 2 variables with the variables as variables or its negation. Now if you have 3 variables, all the variables should be present in each term. Then only they are called min terms, right? So here Q is missing, in the second one R is missing, in the third also R is missing. So how to introduce that? Let us consider one by one. So here let us consider so this is what? This is actually CNF, conjunction of normal forms. Okay, conjunctive normal form. This is conjunctive normal form. But it is not PCNF. This is conjunctive normal form. They are not min terms. That's why it is not PCNF. So whichever variable is missing, we are going to introduce. One by one, well, let us see. So PRR. First, let us consider PRR. One second, my pen is not writing properly. So first consider the first term PRR. Okay. So what is missing? Q is missing. So PRR is equivalent to P. I am going to write it as PRR RF. Here you have R. So I am going to introduce F. PRF is P only. Okay. So PRF is P. If you want, I'll explain how. P, F, T, F, F, F. So if you write PRF, what will happen? Here T, F. What is TF? It is P. TF is P. Here you have so here you have TF, that is P. Here also you have TF, that is P. Okay. That's why PRF is P only. And we know that P and not P is F. Okay. So any variable and its negation is always false. So I am going to introduce now whichever variable is missing, introduce that variable. That is P, R, R, R. Now we have which is missing, Q is missing. So Q and not Q. That's all. Very simple. Now you have to take the distributive law. Apply distributive law. Here I have R and. So P, R, 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 Q. Right? P, R, 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 not Q. In between and. So that is equivalent to, now I am going to write in the order so that it will be easy for me. So P, R, Q, R, R and P, R, not Q, R, R. Okay, this is the first term. Let us take this as equation number 1. Now consider the second term. What is the first term? P, R, R. This we have completed. Next, not P, R, Q. Let us consider not P, R, Q. So not P, R, Q is equivalent to, which is missing? R is missing. So not P, R, Q, R, F. This is equivalent to not P, R, Q, R. So R is missing. So R and negation of R, I am going to take it. And now you apply the distributive law. That is not P, R, Q, R, R. Not P, R, Q, R, negation of R. In between and. So this is equation number 2. In the same order I have, so I am not going to change. Now consider the third term. What is the third term? So first is over, second over. Now P, R, not Q. Third term is P, R, not Q. Consider P, R, not Q. So P, R, not Q is equivalent to P, R, not Q. Whichever is missing, for that I am going to introduce F. So missing variable for F, I am going to introduce the missing variable and its negation. So P, R, not Q, R, R and not R. That is equivalent to, now you apply the distributive law. So please write the, for exam you write the reason also, okay, whichever law you are applying, please write that. So P, R, not Q, R, R. P, R, not Q, R, not R. In between and. So this is equation number 3. Now you write all the terms, all the expressions together. Combine all these 3. We want and between 1, 2 and 3, right? So 1 and 2 and 3. And please remember, whenever you have repeated terms, you can leave them. You write only once. Okay. So combining 1, 2 and 3. We get PCNF. PCNF of the given formula yes. Always remember, you assume that the given formula is yes. Yes, you have to write all the 3. So PRQRR, PRQRR and second one is PR not QRR, PR not QRR. Not QRR and now P not PRQRR, not PRQRR and not P not Q not PRQR not R and PR not QRR already I have written. PR not QRR already it is there, so I am not going to write that. So repeated terms you need not write. So PR not QR not R. Okay. So this is the required expression of PCNF. So from this, if you want to find out the Pdnf, I'll explain after that table. Okay. So this is PCNF and Pdnf also we can find out using this. So these are the max terms available, right? So these are the 5 terms we have written. From this you can write, you have PRQRR, so strike off this. Next one you have PR not QRR, PR not QRR, strike off this. Next term is not PRQRR, not PRQRR, strike this term also. Next is not PRQR not R, not PRQR not R, strike off this term. Next term is PR not QR not R. So this also you strike. Okay. So what are the remaining terms, remaining max terms? So this is our PCNF of the given formula S. So from this what can you write? PCNF of negation of S can you write? That is the remaining 3 terms, right? And from that if you take the negation you will get the PDNF. So remaining terms I have written like this. PCNF of negation of S is not PR not QRR, not Q or not R. The 3 terms I have written for negation of S. And how will you find out PDNF from this? Take the negation of S. Okay. So these are the 3 terms which gives the PDNF. The same thing I can use the truth table also. From this, now I have formed the truth table for the given expression. You can go through this. So if you want to write the PDNF, you have to consider the truth values, right? So 1, 2, somewhere I have made a mistake. Usually you will have only 3 terms, right? So this is F. The last one here, 5th should be F. F and F, this is F. Okay. 5th and this one, and between these 2 columns, no. So T, T, F, 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 F. This is also F. Here only T. Yeah. So only 3 terms we have for PDNF. So PDNF means what? You are considering T. So you have to consider the 3 variables here. 3 variables, corresponding variables. You consider the rows in which you have T, corresponding values. Now you are considering T. So PDNF is P and Q and R. Second one is P and Q and not R. Last one is not P and not Q or R. Right? This is what we have written. PDNF is what? PRQRR, PQ not R, and not P not Q R. These 3 terms. Yes. PRQR not R. Yes. Not P or not Q or not R. Right? Similarly, how will you write the PCNF now? You consider F terms remaining F terms, so you will get the required PCNF. You consider F for, you want me to write, I'll write. For F you consider the, if you have F you write the variable as it is. If you have T you take the negation. So PCNF is, we'll be writing not P. So here these are the terms. 1, 2, these 5 terms you will have for PCNF. Okay. So not P. If you have F, you write the variable as it is. If you have T, you write the negation. So not P, R, Q, R, not R, and because it is conjunction of normal max term. So next is P, R, sorry, negation of P or Q or R, and P R negation of Q R negation of R, and negation of P, no, next is P R negation of Q R R, and P R Q R R. This is our PCNF. So whenever it is mentioned using using the truth table or without using the truth table, you have to follow that method. Otherwise, you can use anyone. Okay. Hope you understood. Thank you for listening. And practice more problems so that you will be thorough with these things. Okay. Thank you.